Okay, so there were two questions asked here. I'm going to address them in two separate videos. This is the first. And the question was, given these two ramps, both with the same mass at the top, both with the same height, both with the same spring constant, didn't draw that on there, both with the same spring constant. As you can see, they are essentially the same ramp. One of them just has a longer straightaway. So let's call this ramp A and this ramp B. The first question was, if both ramps are frictionless, as you can see there, if both ramps are frictionless, explain why the block will compress the springs the same amount. So most of you are getting the gist of this when I'm looking at your responses, but not necessarily talking about the transition of energy. Okay, so we're talking about the conservation learning target, the idea that energy is not disappearing over the course of this. Energy is staying the same. It may transition from one to the other. So it's important to note that in the beginning, let's call this the potential energy of A, or the potential energy of the block due to A, that would be mgh, is equal to the potential energy of B, because that is also mgh. Same mass, same height, and therefore the same amount of potential energy. Now, when this block moves down and reaches the bottom, it's important to note that all of the energy that the block had is converted to kinetic energy. Okay, and the same thing happens here. At the bottom here, we have, hey, don't do that. The potential, stop doing that. The potential energy of B is equal to the kinetic energy of B at the bottom. So based on those two things, we can see that since they had the same amount of potential energy in the beginning, when all of that converted down, that shouldn't look like over, the kinetic energy of each at the bottom is the same. Meaning that when the block is here and when the block is here, since all of the potential energy has been turned into kinetic, the blocks are traveling the same speed. Now, we also know that the spring potential energy is equal to 1/2 kx squared. And if all of this energy is going to be converted into spring energy, we know that USA. Oh, that's even funnier over here. USB. I'm going to pretend that was on purpose. So the spring potential from A is going to be equal to the kinetic energy at the bottom, is going to be equal to the potential energy at the top. All of our energy exists in the spring once this block has compressed the spring as far as it'll go. And the same thing here. Since these two have the same amount of, so U spring A is equal to U spring B, and if we wanted to use 1/2 KAX A squared is equal to 1/2. Notice that this is a lowercase k versus the uppercase K for energy. KBXB squared. Since those two K's are the same, everything can cancel and we get that the compression of the two springs is the same. So again, you got the gist of it when I read your work. Ignore that. You got the gist of it when you read your work, but the explanation wasn't quite there about the transitioning of energy types. So keep that in mind for the test on Friday.